So label the sides. Hypotenuse, opposite, adjacent. You want the opposite, you know the adjacent. So, ka, toa. O and A are together with T for tan. So tan, the angle, is opposite over adjacent. Just doing it in the correct order. Bringing that across, 18.4 times tan 30 equals x. So 18.4 times tan 30. So your x works out to be 10.6. That's TQ. Now to work out AT, which is the other side, I would just use Pythagoras' theorem to keep it simple. So 18.4, this is 10.6 and call this y. Add the two at the right angles squared, and it equals the other side. Just putting that all into your calculator, 18.4 squared, add 10.6 squared equals 450.92, and then square root your answer, gives you an answer of 21.2. Okay, the next example I have here is a 3D example. VABCD is a rectangular pyramid. V is vertically above O, which is the centre of the rectangle, like that there. VO, so the perpendicular red line there, is 18 centimetres. The angle between VA and the rectangle is 25. So if I sort of show you in here, if you can imagine that's a right angled triangle, that's O, that's A, that's V, this is 18. The angle between VA and the rectangle is 25 degrees. And BC is 15. Calculate VA. Now, if two pieces of information is all you need for trig, a right angled trig, hypotenuse, opposite, adjacent. I want VA, so I want the hypotenuse, I know the opposite. So, ka, toa. O and H is together for sine. So sine, the angle, is opposite over hypotenuse. So sine 25 is 18 over the hypotenuse. So bring that over. The hypotenuse is called VA, so we'll just call it VA. So VA times sine 25 equals 18. Bring that over and divide. So VA is 18 divided by sine 25. So 18 divided by sine 25 gives me 42.6. So 42.6, just put it on my diagram. I'm now looking for AC. Now if I could work out AO, AC is going to be double it. Now from my wee triangle here, if I just draw that out again, we've got VOA. You know the opposite is 18. You've worked out VA is 42.6 and you know this angle is 25. Because I've got two sides, I can just use Pythagoras' theorem. So Pythagoras' theorem, add the two at the right angles squared. So AO squared plus 18 squared equals 42.6 squared. Bring that to our side and subtract. So AO squared is 42.6 squared minus 18 squared. Now I have that accurately on my calculator, so I'm not going to wipe it. I'll just square that and then subtract 18 squared to give me that answer there. I want AO, so I will square root my answer to give me 38.6. So AO equals 38.6 centimetres. The question wants A to C. That's the whole way across. So A to C is twice that to give me an answer of 77.2 centimetres. Now I want AB. Now if you've worked out A to C, that's a right angled triangle. I'll just squeeze it in here. So there's a right angle at B, A, B, C. A to C is 77.2. B to C is 15, and you want A to B. Just use Pythagoras again. AB squared plus 15 squared is 77.2 squared. Bring that over and subtract. Now I have that answer in my calculator, so I'll just square that and then take away 15 squared to give me 5735.187. To get AB, square root that. So square root the answer gives me 75.73 centimetres. And a wee note down here, all your 3D questions should be right angle based. So if it's a 3D one, you're looking for your SOHCAHTOA or your Pythagoras theorem. Now, the next few examples. ABC is a triangle in which AB is that angle at B. Remember the middle letter tells you what the angle is, 34. The angle at C is that. It does not tell me it's right angles, so I'll just draw out a triangle with no right angles in it. AB is 5.4. The angle at B is 34. The angle at C is 56. I can easily put in the angle at A by subtracting those two from 180. 180 minus 34 minus 56. Minus 56 gives me an answer of 90 degrees. So that did work out to be a right angle. I'll redraw my triangle now. That does make life a lot easier. So that's 90, 34, 56, 5.4. I want AC. Now, I've got two angles. Just choose to work with one of them. I'll work with this one here, the 34. So that's your opposite, and that's your adjacent. So I want AC, and I know the adjacent. So, SOHCAHTOA. O and A are together for tan. So tan, the angle, is opposite over adjacent. Your angle is 34. Your opposite is AC, and your adjacent is 5.4. Bring that across and multiply. 5.4 times tan 34 equals AC. So 5.4 times tan 34 gives me AC to be 3.6 centimetres. Number 7. ABC is a triangle in which AB is 7 centimetres and AC is 9 centimetres. And the angle at B is 84. Now I was given, I haven't been told of any right angles, so I'll just draw it ordinarily first. AB is 7, AC is 9, and the angle at B is 84. I don't see any right angles at the minute. I'm looking for angle at C. So it's either the sine rule or the cosine rule. Now you'd use the cosine rule if you had two sides and the in-between angle, or if you had all three sides. I don't have either of these situations here, so I'm going to use the sine rule. The sine rule is side over sine the opposite angle equals side over sine the opposite angle. Two fractions equal each other, cross multiply. So 9 times sine C equals 7 times sine 84. Bring your 9 over and divide. So sine C is 7 times sine 84 divided by 9. If you notice why I put brackets around that, because if I didn't, I'd be scared in case the calculator had sine divided by 9, which you don't want. So 7 times sine 84 equals, divided by 9 equals, so sine C is 0.7735. To get the angle C, you bring your sine over and you do inverse. So C is inverse sine 0.7735. So shift sine answer to give me an answer of 50.7 degrees. Next one, number 8. PQR is a triangle in which angle QRP is 52 degrees and QR is 3.6 and PR is 5.4. Calculate PQ. Again, I'm not told it's right angles, so we'll just draw out an ordinary triangle. Angle at R is 52. QR is 3.6 and PR is 5.4, and I'm looking for PQ. I'm looking for this side. Now I have two sides and the in-between angle. That's the cosine rule. Now, remember the angle and the side you're starting with must be opposites. So PQ squared equals the other two sides squared minus 2 times the other two sides times cosine the angle. And just make sure your side and your angles are opposite. That's your start and that's your finish. When you're putting this into the calculator, put this section in and then this section. So you have PQ squared equals 3.6 squared add 5.4 squared, which is 42.12 minus 2 times 3.6 times 5.4 times cosine 52 to give you 23.9369. So PQ squared equals 42.12 minus the answer, 18.183. So PQ is the square root of that answer to give you 4.26 centimetres. Number 9. ABC is a triangle in which AB is 13, AC is 11.5 and BC 17. Calculate the angle at A. So 3 sides, I know it's going to be cosine rule. I'll just draw up here. So it's A, B, C. And you were told AB is 13, AC is 11.5, and BC is 17, and the angle BAC, remember the middle letter tells you the angle, is what I'm looking for. So cosine rule. I want this angle, so I start with the side. So 17 squared equals the other two sides squared minus 2 times the other two sides times cosine the angle. Okay, make sure they're opposites, start and the end. So 17 squared is 289. And remember you do them in 2 halves. This section and this section. So 13 squared plus 11.5 squared gives me 301.25 minus 2 times 13 times 11.5, 299 times cosine A. Going to rearrange this, numbers all together, bring that over. That becomes a take away because that's a positive number. That negative is attached to this term. That's a positive, so when it comes over it becomes negative. 289 minus 301.25 equals negative 299 times cosine A. So 289 minus 301.25 gives me minus 12.25 equals, now negatives on each side, just ignore them. That 299 is now multiplying, bring it across, it becomes dividing. Equals cosine A. We're just working that out. So cosine A is 12.25 divided by 299 to give me 0.04096. And then bring your cosine over and do inverse. Now I will go inverse answer on my calculator to keep it accurate. So shift cosine answer. The angle there is 87.65 degrees.